Here's an example of using macros to do a simulation. So say I've got this data set here. It has, I think, 33 x1 and x2 values in it. And what I want to do is run this simulation to see if the parameter estimates of B1 and B2 actually have the distribution that I would expect for them to have. So here's what I'm going to do. I'm going to do I equals 1 to the number of reps that I do. So I'm going to call this for 50 reps. And then I'm going to create the data set and then run a regression procedure on it, and then we'll append things together in just a minute. So the data 1 is going to be the set of x values, and then I'm going to create some y values by saying it's going to be the intercept plus my value for the first slope, my value for the second slope, and then I've got some error that's normally distributed, like we always assume. And then I'm going to run this regression procedure. Then the output for this regression procedure is going to be the intercept x1 and x2. I'm going to just keep those three variables are going to be the variables in my new data set. And for each regression procedure, I'll only have one observation in this data set. I'll only have one intercept and slope estimates for x1 and x2. I'm not going to print this out every time I go through the regression procedure. I'm just going to keep it. And then what I'm going to do with this new data set that has that one single observation, intercept x1 and x2 parameter estimates, is I'm going to append that data set to the final data set. So what this is doing, if this creates a data set new, okay, new has intercept is -9, x1 is 0.4, and x2 is 6. Say these are my values for data set new. Then append is going to create this proc append is going to create this data set called final, and in final I'm going to stick this as my first observation, -9.46, because I'm appending data new. Then I'm going to go through the do loop again. This is a macro do loop, so I can go through this whole thing again. I'm going to create another data set and get another intercept x1 and x2, and that's going to be my new data set new. So this gets erased and replaced with the new intercept and slopes 0.6, say, and 2. And then the proc append now is going to append this data set. It's not going to replace data set final, like we just replaced data set new, but rather it's going to add this on. So this is going to be the second observation, -8.6 and 2. So now my final data set has 2 observations. So you can see if I loop through this 50 times, my final data set should have 50 observations. And then at the end of the macro, once I get out of the do loop, the macro do loop, I'm going to print out this data set final. So that's what the data set that does. Also, because I've run this program before, I already have a final data set working, and it already has final 50 observations in it. So what I want to do is get rid of that data set, and proc data sets will do that for us. I can just delete final. Final's the name of the data set that I've created. So I'm going to go ahead and run this before I run through that macro again. It takes a minute. You may want to consider using a proc IML instead of a proc reg, because the regression procedure, remember, calculates things like the ANOVA table and R-squared values, and other stuff that you don't want. So here's what happens when we get this final data set. You can see how I've got intercept x1 and x2 slope estimates, and they look pretty good. We were expecting 3.3 and negative 10 over here. So now I can do things like create proc means to see if on average I'm hitting my negative 10. It looks pretty good. This should be a 0.3. These things look pretty close. I mean, at the very least, within my confidence interval is the true parameter values. So it looks pretty good, and those confidence intervals are pretty small. I can also run something like a G chart to see if these parameter estimates really have the distribution that I think they ought to have. So I can check on these things, make sure they're normal. They're looking a little bit skewed, so I might want to go back and see what's going on. But this just gives me a nice way to check out the distributions of my parameter estimates.